about some of the best practices that are associated with exception handling in Java. So the first one that I have here is to catch as specific of an exception that you can. So what I mean by this is that you should try to avoid catching exception or error or even runtime exception. The reason for this is because you'll end up catching a lot more than you might have bargained for. And really, in cases where you're catching a general exception, it's very unlikely that you're going to be able to do anything really useful. And there are, of course, a few exceptions to this rule or this guideline when you're trying to just log something and you don't know what it is, or maybe it's a catch-all for if you've tried to catch some specific exceptions, but you have this other exception that may have existed and you need to do something, you need to log it. But in general, you want to be as specific as possible, because the more specific of an exception that you catch, the more likely that you're going to be able to do something good or do something beneficial with that exception when you catch it. And also, you're not going to take away that exception. It really is bad when you just catch the general exception and you end up catching exceptions that maybe somewhere else in the code or higher up the call stack someone could have done something with, something meaningful, and you've caught that exception because you had made your exception handling too wide. The next best practice, this one is somewhat debatable actually, is exceptions are for exceptional situations only. And I kind of lean on both sides of the fence. I kind of straddle the fence on this one. It kind of depends. This is really a difficult topic, and there's some good arguments on either side. I tend to probably lean more on the exceptional situations, but there are certain times in the code where I think it does make sense to use exceptions for what some people might say is flow control of your program. And I don't use that lightly. You definitely shouldn't use exceptions in general for flow control. It's not a way to get out of a loop. It's not a way to jump around in your code. But if you have some logic and you have an error condition, even an error condition that you could have detected, sometimes it makes sense to use an exception there. A lot of programmers would say never use exceptions except it's something that you couldn't have checked without an exception. Something that, like reading a file and that file doesn't exist, and let it throw that exception. In fact, they might even say, well, check to see if the file exists, and avoid throwing the exception or handling the exception. But in general, this concept or this best practice is based on this idea that you really shouldn't just be using exceptions everywhere. You shouldn't be just throwing exceptions in order to change the flow of your program. Exceptions are really for error conditions. If you kind of follow that spirit of using exceptions, you're going to have a lot less of exceptions littering through your code, and really your code's going to be a little bit more performant, because using exceptions is not the most efficient way to, for example, exit loops or to jump around in your code. Another important best practice, we'd kind of mentioned this before, this one's specific to Java, which is do not catch errors. We saw how there is the unchecked exception that inherits from error, and everything that inherits from error there, and any exceptions in that class you really shouldn't be catching, because those are critical things that you might not be able to even guarantee that you could do anything with. So I'll give you a good example here, which is out of memory exception. If you get an out of memory exception and you catch that, what are you going to do? You're out of memory. You can't guarantee that you're going to be able to do anything. So it's really going to give you kind of a false sense of security, and it might even cause more problems. If you're low on memory and you're getting the out of memory error, and then you try to do something, you might really cause a big problem, whereas the program could have just crashed and dumped a stack trace, and you could have figured out that you're out of memory. But if you try to do something, you might make it even more confusing. So in general, you shouldn't be trying to catch errors. It's really unexpected that someone would put a catch block in that catches errors, and because of that, if you do that, you could end up having code that it's really confusing to someone because they're thinking, well, where did this error go? I didn't expect anyone to actually catch this. And then this one is really important. This is kind of near and dear to my heart as far as best practices for exceptions in all languages, and especially Java, is don't just catch an exception that you're not going to be able to do something with. It's the way that what we call this is eating an exception. And every time I see this in code, I cringe because this is really bad. And what this means is a lot of times you'll see this where someone just puts catch exception, and then inside of that catch block, they don't do anything. And they just eat the exception. And that's really bad because, one, you don't know what has happened with your code. Some bad thing has happened, and if you put that in there, you're not going to find out. It's just going to go on its way. It's like exceptions don't exist. An exception happened because there's an error. And so if you're going to catch an exception, you need to make sure that you're going to be able to do something with that exception and not just eat it. And the other reason for this is because if you eat the exception, you're basically stealing lunch from someone else. Maybe someone else could handle that exception and do something, but because you've ate the exception, that exception's gone, and the code that could have actually handled. So let's go over what we covered in this module. Well, the first thing that we did is we talked about exceptions in general and got kind of a good understanding of why exceptions exist in Java and when you would use them, and kind of the whole idea behind exceptions. Basically that they make error handling a lot easier in your code rather than trying to pass back error codes like you might have done back in the C days. Then we looked at some code. I showed you how to actually implement exception in Java, and we covered some of the basic here. We didn't cover everything that has to do with exceptions, but I showed you, the basics of setting up a try block and a catch block in order to be able to catch exceptions and deal with exceptions. Then we went into the finally statement, and I showed you how to set up a finally block, and we learned that a finally block can be used to execute some code regardless of what happens, whether or not there's an exception thrown or the code executes normally without an exception. Then we talked a little bit about checked and unchecked exceptions, which are the basic two types of exceptions in Java. We talked about how checked exceptions have to either be caught or you have to specify that you're going to throw that exception in your method, and how there's kind of strict rules around this. Then we looked at unchecked exceptions, and we saw that unchecked exceptions basically don't have to be caught, or that they don't have any rules surrounding them, and that these kind of exceptions are typically exceptions that you might not really